Hello, good day. So I'm over at brilliant.org. This is a website that I was recently introduced to. I've only had a quick look around, but I thought it'd be very cool to do an entire series of videos where we basically just work through every problem on this website, starting from algebra, and we move through to geometry, number theory, calculus, discrete mathematics, basic mathematics, all the way through to classical mechanics and beyond. I thought it would just be a really neat series to do. And my idea too was that, before start solving each problem, if you want to pause the video, work out your own solution, and then we can compare solutions, you can review my notes, etc. I'm got a little notepad here that I'm going to position, so it can take up half the screen, and then I can write out my own work. Okay. So the first problem, again, this is chapter 1 of the algebra section of the website, under the heading Scale and Lever Logic. Okay, I've reviewed one or two of these problems just to get a sense of how things, how the website is, if how it works, etc. Okay, so scale and lever logic. How much does a single red square weigh? On the first illustration, we have one red square with two purple dots, and that weighs 20 grams, it says. And then the second illustration, we have one red square, one purple dot, 15 grams. There's a really quick way actually that you could solve this that's really very simple and very quick. But because this is part of the algebra section of this website, I'm gonna come up with an algebraic solution. Okay, so basically what we could say for the first illustration, and again, if you want to pause the video before I start working through it, go ahead. I'm going to say what r plus 2p equals 20 grams, right? I'm going to denote this as 1, set up a bit of a system of equations maybe, and then in the second illustration we have r plus p equals 15. Okay, I'll denote that as 2. And now basically, I'm going to solve for p in second equation here. We're going to say p equals, I'm just going to basically subtract r from both sides, so it'll be 15 minus r. Okay, I'll just highlight that. And then what we're going to do is we're going to substitute this value of p into top equation here, where it would be r plus 2, and of course p equals 15 minus r, so we're just going to insert 15 minus r here, and then we're going to set that to equal 20, and now we can simplify. We're just going to expand this out, right? 2 times 15 and 2 times minus r, so we can now write r plus 2 times 15 is 30, 2 times minus r is minus 2r equals 20, and then we can subtract 30 from both sides, so what we're left with is r minus 2r equals 20 minus 30, and then again we can simplify. This is just going to be minus r on the left side, right? R minus 2r, and then 20 minus 30, that's just going to be minus 10, and then we can divide both sides by negative 1, and that's going to give us r equals 10. Alright, so the weight then of a single red square will be 10 grams. And you've got it right. The other way that you could have done this immediately comes to mind. You just basically subtract. You'd say, you would 20 minus 15, which would equal 5. And then you would subtract 15. So 15 minus 5 would give you 10. So 20 minus 15 would give you the value of one of the purple discs, circles, and then 15 minus the weight of that single purple circle would have given you 10, which would have given you the weight of that red square, but we found it algebraically. So, okay, on to the next problem. Scale and lever logic. This course investigates how logic intuitively applies solving problems Pulses, mirrors. So this actually doesn't appear to be a question. It's, I don't know, somewhat of an introduction, I suppose. Okay, but here's our second problem. So I'm just going to erase all of this quickly. And it says here that we've got one full jar of honey that weighs, 1,000 grams. We've got a second jar of honey that is exactly half, and its total weight is 600. And the question is, what is the weight of the empty jar in grams? Okay, well, they're giving us the key information right here in relation to these the first two jars. What we can do is we can subtract 1,000. 1,000 minus 600. Okay, that's going to give us 400 grams. That's the difference between these two. Exactly half this is basically, you're subtracting 400 grams to get exactly half, to get this jar, right? Now to find the total weight of the empty jar in grams, we're just going to subtract 600, because this is exactly half. We know that there's 400, right? We're going to subtract 400 grams. Oops, I don't need to put that. 600 minus 400 is going to be 200 grams. That's our answer. I should write it a little bit more neat, I suppose. 200 grams. So that's the answer. That's how much the empty jar weighs. And we got it right. Okay, next question. Okay, this one looks interesting. Let's see here. Scale Novalogic. What weight will the fourth scale display? Think carefully. There's a quick and clever shortcut for solving this problem. So in the first illustration, we have a rabbit and a cat, and that equals 10. I don't know what the value of the weight, but okay. The second illustration, we have a rabbit. Looks like a rabbit and a dog. That equals 20. We've got the cat and the dog. That's 24, and they want to know the total weight is of one rabbit, one cat, and one dog. So the first thing to think of, and if you want to pause the video before I go through it, the first thing I think of is that we can probably get the weight of each individual animal separately and then add them all up together. But there might be a quicker way to think about this, and we're going to use a bit of algebra. So we're going to say, similar to the very first problem, we're going to say R plus C equals 10. Rabbit plus cat equals 10, right? Rabbit plus cat. And then we're going to say R plus D equals 20. We're going to say C plus D equals 24. Okay, I'm going to note these 1, 2, 3. Again, you could probably set up a system of equations, but actually what we can do here is if we add all of this together, so we have 2R, 2R, and then we've got 2C, 2 cats, and we've got plus 2 dogs, and then the total weight of all of this is 10 plus 20 is 30. It's going to be 54. Okay, so basically we're taking the total weight of all three of these illustrations. Okay, and therefore we end up with 2 of each animal, as they appear twice in each picture. And then we want to basically find the weight for just one. So here's the weight for if we had 2 rabbits, 2 cats, and 2 dogs. It's going to be 54. We just want 1 rabbit, 1 cat, 1 dog. So we can divide by 2. This entire thing right here. Divide by 2. That's going to leave us with R plus C plus D. And 54 divided by 2 is 27. Just gonna double check. 7 times 2 is 14. Yeah, 54. Okay, so 27, and that is our final answer. Yeah, I'm going with 27, and it's correct. Okay, Let's do the next problem. This one looks interesting. It says, okay, scale and lever logic. At the end of this course, you'll have a thorough toolbox of algebraic techniques, blah blah blah. No, that's not the actual problem. So the question is, how many green squares should be placed on the right side of the bottom scale in order to make it balance when released? So here we've given two diagrams. The top one, which has got our critical information. We've got 3 green squares and 1 red or orange triangle, and that's exactly balanced. It equals 1 blue circle and 1 orange or red triangle. They want to know how many green squares then should be placed on the right side of this balance. Well, we could again do it algebraically, couldn't we? We set up, because they are denoted by color, we could say R plus 3G equals, well, I mean, we could look at just actually logically. If we cancel out the both triangles, right? If we just cancel them out, because they cancel out, then we're left with 3 green blocks equals 1 blue disk, 1 blue circle. And so on this one they have 1 blue circle plus 2 green blocks. Well, if 1 blue circle equals 3 green blocks, so that's the equivalent of 3 green blocks right there. We could, if I could write on this page, I would just write 3 right here, 3 green, and then plus 2, so it's going to be 5. That's the answer, because it's already got, yeah, it's 5. Don't really need to do much more with that. Okay, next question. Scale and Novalogic. We also delve into applications of algebra and physics. Okay, so this must be just the introductory chapter. I mean, I guess, yeah, it says right there, introduction. Which way will the balance above tilt if released? Okay, so this is a fun one. I haven't done one of these problems in a long time, actually. So if what I remember is that force equals weight times distance from fulcrum. Okay, when dealing with lever problems such as this one, the fulcrum is this point. It's the point on which the lever turns or is supported. Okay, that's the fulcrum. So the formula here is force equals weight times distance from fulcrum. So in this case, on the left hand side, we have 15, we can set up an inequality actually, yeah, 15 times 50, okay, which is going to equal 15 times 50 is going to equal 750. Okay, and then on the right hand side we have 120 times 5, and 120 times 5 is going to be 600. Did I do that right? Yeah, okay. Now we can just set up an inequality. That's basically what we're going to do. You can see that the left hand side is actually a lot heavier, right? 15 times 58 equals 750. 120 times 5 is 600. So 15 times 50 is greater than 120 times 5, which is to say that if they're asking us which way will the balance above tilt if released, it's going to tilt left. The left side is heavier. So our solutions, it will drop down on the left, it will drop down on the right, it will remain level. No, it's going to drop down on the left. Correct. Finish quiz. Okay, you read one page, completed 5 problems, got 5 corrects. Excellent. In the next video, we'll do the next quiz, but that's all for now.